in synthesis, so alkyne synthesis. I encourage you to pause this video and kind of run through it based off what you've learned so far in the course and kind of put your knowledge together. But this is just for practice. So, what if you were given this and you were asked to provide the necessary reagents to get to the observed product? How would you think of it? Well, the first thing I always do when I look at these problems is to look at if the carbon chain is extended. So let's see. I have 1, 2, 3, 4 carbons here, and we could assume that this methyl is the same thing as here, so that's why I didn't count that. But let's see. So we have 1, 2, 3, 4, right? And let's include a methyl. So we have 1, 2, 3, 4, 5 carbons here. Here we have 1, 2, 3, 4, 5, 6, 7. So you could see that we have enhanced the carbon chain by 2, right? So the first thing I would do, because there's no way, so the first thing I would do to kind of get to this molecule is I want to extend the carbon chain. I have 5 here. I need 7 first. So the first thing I'm going to do is extend the carbon chain. So taking this molecule, right, I'm going to extend the carbon chain. So the first step I want to do is add sodium amide. And what this does is that it takes all this hydrogen and gives me a carbon anion, which is ready to attack something to attach, right? So in the second step, I'm going to add this reagent. And the reason being is that notice that how many carbons now I'm adding, right? I'm adding 1, 2, right? So again, now we'll get something that looks like this. Right? We have a bond that's bonded. We have a bond that's bonded to this carbon that also has another carbon on the end. So that's how the first thing I do is extend the carbon chain. All right. So now that we've gotten to this point, what we could actually do is that we could get an alkene. We could get an alkene, right? We could get an alkene, and then we could do that bromine Br2 in the presence of water, right? So I'm kind of thinking through this as we go along, guys, right? So we could get this to an alkene, right? So we could add, it doesn't really matter in this sense, right? But we could add, because the Br and OH are actually opposite to each other, it doesn't matter in this sense, but I'll add sodium solid in the presence of liquid ammonia. And you could also add Lin large catalyst. It doesn't matter in this sense. And it will get me to something that looks like this. Now I have a carbon-carbon double bond bonded to that, and there's my 2 hydrogens in which I added. All right. So now that I have that, this is just simply the reactions of alkenes. Now we add bromine in the presence of water, and that just gives me anti-addition. In this case, it doesn't matter which one the water goes on because both of them are equal in terms of substitution pattern. But because this is an observed product, we're going to just follow the observed product, and we get our final answer to be something like this. So the first thing you want to look at with these type of reactions is look if your carbon chain is extended. So this is how we provide this reaction given that thing right there. So how about this one? How about if we have, maybe we should label this as 1. How about number 2? What if we have, let's see. What if we had this? What if we added this alkene here? And we got something to be something like this. We got something to look exactly like this. Right? How would we provide the necessary reagents to get to this product? Well, again, the first thing you want to look at is if your carbon chain is extended. So let's see, we have 1, 2, 3, 4, 5, 6 over here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we differ by 4 carbons. We differ by 4 carbons. We differ by 4 carbons, right? So we have an alkene, we have an alkyne. Notice that there's no way currently that we know of to get from an alkene to an alkyne immediately. So we have to take a step backwards, but really it's a step forward, right? So what I could do is actually do halogenation on this alkene right here, right? So if I take this molecule and I added Cl2, what will happen? Well, I'll get something that looks like this. I'll get a chlorine here, and I'll also get a chlorine here on the carbon-carbon double bond, right? With my hydrogen there. All right, so this is what I'll get. Now you see that we could add sodium amide, right, to kind of kit these right? We could add sodium amide now to kind of kit these chlorine off to give us a product that looks like this. Right, will give us a product that looks like this with the carbon that's negatively charged. Now remember, if we added water, now this would have had some sort of proton source. So that's why I didn't add any water. So now that I have that carbon that's negatively charged, I could just add how much the carbon chain differs by, and we already said it differs by 4. So in the last step, we could add this molecule here. Right, notice that the bromine will leaves, which leaves me with 1, 2, 3, 4. Leaves me with 4 carbon, right? And we'll get the neutral product, or the product observed at the top. That we've seen. All right. Now, for those of you who wonder how we add this, and how it happens in between this one and this one, just a quick take. A side note. All right, this negatively charged carbon. Once I take this and add, and maybe we should show the mechanism here just so it makes sense. Once I take this negatively charged carbon and react it with this molecule, this will happen. These electrons are nucleophilic, so it comes in, attacks the carbon that contains the halogen, and kicks it off. So this is a classic SN2 reaction. Kicks it off, and now this whole thing right here is bonded to this, right? So we get the molecule that looks like this. All right, and it's the same thing that happened right here, right? These electrons, I didn't show the intermediate step here, but this will protonate. This will leave a negatively charged carbon, and then this just comes and attack the carbon containing bromine and expel the bromine.